In this tutorial, you're going to learn how to build a full-stack application using SvelteKit with DataStax's Cloud NoSQL database AstraDB. The features we will build will be part of a community platform demo project. In this community platform, we'll discover how to more easily find community members and their GitHub profiles. We will want the ability to list developers, add, delete developers, and filter developers. The web application will be a single-page web app with search at the top, followed by the form to add a developer, then below the form will be the list of the saved developers and their information. The web app will load the list of developers over a RESTful API using GET requests, which is the same for the search form. When submitting a new developer via the form, the web app will send a RESTful POST request to the API, which will save the body of the POST request in the database. By using open source tools like SvelteKit, Bootstrap, AstraDB database, you will gain the foundations for making applications that have no scale limits, allowing you to create your ideas into real projects. As you can see behind me, this is what the app will look like. As I mentioned, we have search. We also are able to add developers, where we have a link for more information that can go to a link of their choice. To complete and make the most out of this tutorial, the following are required. You need Node.js installed, ideally the latest version, but anything above version 12 should be okay. You need to create an Astra DB account, and you can log in with your Google or your GitHub account. A credit card is not required. Their free tier is more than sufficient for this tutorial and your side project. In the following sections, I will give you a brief explanation and description of the tools we're going to be using. So what is SvelteKit? You might have heard of Svelte. Well, SvelteKit is the framework built on top of Svelte, very similar to how Next.js is built on top of React. It builds web applications of all sizes with flexible file system-based routing. Unlike other single-page apps, SvelteKit does not compromise on SEO, progressive enhancements, or the initial loading experience. But unlike other traditional server-side render apps, navigation is instantaneous for that app-like feel. You can go learn more on the SvelteKit website. So what is DataStax's AstraDB? DataStax built a data API gateway into AstraDB so that app developers have an idiomatic JavaScript API stack that works great with the Jamstack or any other JavaScript front-end stack of your choice. AstraDB is built on top of the rock-solid NoSQL database engine Apache Cassandra that powers platforms like Netflix, Instagram, Yelp, iCloud, and so many other apps we use every day. Cassandra is an open source project, and so is AstraDB's Stargate. No surprise there. This is me. There are multiple ways to connect and work with your data, from a RESTful API, endpoint over HTTP, GraphQL to Cassandra query language, CQL. In this tutorial, we'll be using AstraDB's document API and Astra.js's JavaScript library. So why are we using SvelteKit and AstraDB together in the first place? Jamstack providers can make your app globally available via a content delivery network, CDN, or edge network in seconds, and you've gone from desktop to cloud worldwide deployment anywhere. But what about the data? That's what AstraDB gives you. It's a perfect companion to Jamstack apps as it brings data to your app at a commercial, internet level of scale, reliability, and performance on any cloud using straightforward JavaScript. You can learn more on the DataStax website. They have loads of examples on different libraries, tooling, and frameworks that you can use. So first of all, we need to create a SvelteKit project. And to create a SvelteKit project, let's run this command. We will run npm init svelte at next, and we'll call this project Svelte DataStax video. Do we want to proceed? Yes, please. There are two options that are provided. We can go for the demo app or the skeleton project. With the demo app, you'll get some features as examples, but in our case, we're going to build from scratch. Let's go for the skeleton project. You can use TypeScript or not, which is a really nice feature to have, but in this case, let's keep it simple and let's go for no. Do we want ESLinting? Again, let's keep it really simple and go for no, but I really do like ESLint. And again, for prettier, I'm gonna go for no, but I would highly recommend to go for yes for these in your projects. So now it's given us the next steps that we need to take. So we need to cd into the project that we just created, which is Svelte DataStax video. We're in there, it says run npm install, so let's do npm install and let's get the dependencies installed. Then it recommends we commit to Git, but I want to leave that out. I'll let you do that for your projects. And next we can run npm run dev. So now the project is running. Of course, this breaks because there is no root for developers yet. We're going to work on that. And it straight away says, welcome to SvelteKit. So let's just check everything is working. It looks pretty promising. Let's just double check. So what we need to do is open VS Code to start with. We'll make some changes to code to make sure the reload is all working correctly. But what we've got is we've got our node modules and we've got SvelteKit config. We're just going to leave that there. And yeah, node modules that you're familiar with already. Source folder we'll come back to in a moment. Then we have a static directory where you put your public assets in. Favicon, robot, txt, those sorts of things. Your usual git ignore. And as you can see, SvelteKit is a generated folder and it's going to be ignored as well. So you can ignore that at the top. Got a package JSON that you're also going to be very familiar with. And we've got a few dependencies here. We are going to add more coming up shortly. So let's go into the source directory and we can see we have a root directory and app.html. And we've got app.html, and this is the main file that your app uses to render your page. So it's gonna be the layout, and our actual Svelte files will get injected into this. So let's have a look. So this is the layout, and then the page itself says welcome to SvelteKit. So if I change this to welcome to EdiHub, and I will put a link to EdiHub down here, edihub.org. Let me hit save. Let's have a look. Without even refreshing the page, you can see it's already been updated. So we know our app is working correctly. It's always good to check each step of the way. I do encourage you to make your own changes. This way you'll remember it a lot more and you'll learn a lot faster. And each time you add value to your project, don't forget to make a commit so you've got a save point of your project. You don't have to push it straight away as well, but I recommend you do, ideally to a branch. So now let's make a list of developers, and we're going to keep it really simple. We're going to use the HTML, UL, and LI. That's an unordered list. And we'll start this up later with Bootstrap. There is one item in the list. Let's just duplicate it and do 3 of those. Hit save, go back to the web page. We can see it's automatically reloaded and showing us the hard-coded data that we've got. Now we're going to create the API. So already we're straight away into the API. So we're excited to learn about the full stack process. We are getting into the details straight away, and you're going to see how straightforward this is. This will allow the UI to be updated dynamically from the API. And at a later stage, when we connect the API to a database, you have a real full stack app that will work completely dynamically and driven by the database. If you're using Svelte standalone, we could use Express.js for the API, but as we're using SvelteKit, it comes with a lightweight web API framework built in. And the way we do this is we create another file, and it has a special name. So it's going to be index, and then it's going to be JSON.js, and that allows Svelte to know that this is an API endpoint and should be served up differently to the Svelte file. And to create an API in SvelteKit, it's actually really straightforward. So now we've got the root sorted. It is just plain JavaScript. We'll export a function. It'll be called get, and we will get a request and response, a bit like Express.js. And then in here, we will return an object that needs to have 2 properties. Status, so we're going to say 200, and body. And in our body, we're going to return an array. And this collection is going to be our developers. So we'll have an ID of 1, and this will automatically be generated by the database when we integrate with the database. We'll have name, Eddie. Just going to duplicate that, add another person, so there's 2 results. And remember, on the front end, we have 3 hard-coded. And when we change the UI to connect to the API, we will see 2 results from the API, not 3 that we see at the moment. And so now we save that, and if we go to the browser, nothing will change. This looks exactly the same because we haven't connected the 2 yet. But if we append this with index.json, so we know we want to hit the API rather than the UI, you can actually see the data that we just hard-coded in the API. So we're getting closer, we're going to join the 2 together next. Even though the data is hard-coded in the API, once the front end connects to the API, the front end will not know the difference once the API connects to the database, because the data returned will be exactly in the same structure. The benefit of starting off with this hard-coded data in the first layer, the UI, is that we can focus on getting immediate feedback that the app is working. I mean, automated end-to-end testing would be great here too. This is a discussion for another time. Then when we build the second layer, the API that we've just built, we can check that this works independently. As you saw in the browser, we can see the JSON is displayed, giving us confidence that these two pieces work together, and when we connect them, they should still just work as they already are. This really reduces bugs and allows us to work more efficiently. So next, in the index.svelte file, the UI file, we want to create 2 script tags. The reason why we're having 2 is one is going to be special. It is going to have context module. And this is where we'll call the API, and it will run before the component is rendered. It receives a special fetch property with extra features, but these are not needed for this application. So we're going to fetch our API data, and we're going to save it to the variable data. This fetch object we're going to use, but we're not going to use any of the extra features that have been injected in. As you saw in the browser, we're going to go to localhost 3000 index.json. If the response we get back from the fetch call is okay, then we're going to save that to a constant data. And we want the JSON from that response. And we want to return the data as a props to our component. But in the second script tags, we actually want to export the data so that we can have access to it in our component. And so what we can do is now in the HTML, we can delete that, and we can wrap the li in the loop tags provided by Svelte. In this case, it is hash each data as, and as we loop over the collection, we're going to pull out of the object name, bio, avatar, and URL. And then we want to close the loop. What you'll see, this is still hard-coded, so let's make these dynamic, and we can just say we want name, then it's going to be comma, and then we're going to change this hard-coded part with bio, and then we're going to change this hard-coded part with URL. We're not using avatar for the moment, but we will shortly. So if I hit save, we've got an error, we'll figure it out together. Res is not defined, so res is here. It isn't defined because I put rest. Probably what I need to do now because it is quite late in the evening. But you know, I enjoy sharing some knowledge with you, so I'm keen to continue going. But I want to make a few more mistakes. If you notice anything, leave a comment below and let me know. So I hit save and I didn't refresh it, but now I've saved it. You can see 2 results. So there were 3 hard-coded, and I purposely put 2 in the API that's still hard-coded in the API. So therefore, when it got displayed, you know that it has changed. And I can prove it to you. So let's go back to our API file, the index.json.js, and we've got Eddie, Jowd, founder of Eddie Hub. Let's make a change and GitHub Star of the Year. So hit save. And without even refreshing, you can see it's already updated. You can see the extra text here. So we have got a full stack application without a database yet, but you saw how straightforward that was. And it isn't much harder to add a database. You're going to see. So hopefully you're having fun. If you are, give this video a thumbs up. And while you're down there, subscribe and hit the bell button so you get notified every time I post a video and go live. The next part will be the first part of the database integration, and we'll be able to get the data. But we need to manually insert some data first, so when we query for it in our code, there are some results. If this is familiar to you, feel free to jump ahead and add the form that creates the data. Otherwise, we'll get to that shortly. So next we need to log into Astra DB console, and I prefer to log in using my GitHub account, but you can log in with your Google account if you wish, or you can create a new account with them. All I have to do is click login with GitHub and it's going to go straight into my dashboard. To learn more about creating databases and granting user access, please go to the official documentation. They're keeping it up to date as they make improvements and changes and add new features all the time. I'll be using my YouTube database with the Keyspace Svelte Live, and the Keyspace is a collection of tables, which is really good because you can group that together per client, per community, and therefore if they ever want to delete that data, you don't have to go through a table and pick out their rows or anything like that, or their documents. You can actually just delete the entire key space and every table underneath that will go as well. It makes your queries a lot easier and cleaner. As we have not created the form on the UI just yet, we need to manually insert the data via a curl command. To connect to your database, either by curl, HTTP, or any other of the awesome ways you can connect, you will need the AstraDB ID, AstraDB region, AstraDB key space, and AstraDB application token. You will need to create a token for your application, and this can be done from DataStax's dashboard under organizations. When you're in the database, if you go to connect, it gives you your information already, as you can see here, but the token, it doesn't, because you can have multiple tokens with different access. And notice that your key space will be your first one, and you can change this to any one that you want. Here you go, it gives you a link straight away on creating token. When creating a token, you can use the database administrator role for this situation. However, I recommend using the minimum permissions required to achieve what you need when making your own applications and key spaces for your own projects. I've now set my environment variables in my terminal, so therefore you can't see them, so I don't want to show you my token. Remember to treat your token like a password. So what we're going to do from the DataStax docs, we can connect to the database using a curl command. This is the curl command we're going to use to add a new developer to our database. And as you can see here, we're making a post request because we're creating data, and we're going to use the AstraDB ID from our environment variables, same with the region and same with the key space, but we're going to use the collection developers. And also our token is going to come out of the environment variables. And the data we're going to send through is we're going to send name, we're going to send bio, and we're going to send a URL. So if I hit enter, we should get an ID back, and that will be the document that got created. So we do have now a document in our collection. Let's just create one more. Now you see we get a different unique ID. You can run this multiple times to insert lots of data. However, don't forget to change some of the data, like the name, bio, and URL values in the JSON body that is sent with the curl command, so you have a variety in your data stored in the database. And soon you'll be able to do this via the front end in Svelte, which we're going to get to shortly. So next we want to connect to the Astra DB. We want to connect our backend API to Astra DB so we can read and write and remove the hard-coded data and have the data fully dynamic. So now if we stop our application, and what we want to do is we want to add the Astra.js library. So what we need to do is do npm install Astra.js, and it's the collection project that we're going to be using. Remember to add your environment variables to your terminal where you're starting the application so we can use it within the application. And there are libraries you can use with env files. Just make sure you do not commit your credentials to the project. They will be the same credentials that we use for the curl command, so I'm actually going to run the application from here so it loads those environment variables. npm run dev. And remember, whenever you change the environment variables, you'll need to restart your application so it can pick up the new environment variables. So now let's go back to our API in our application, and we want to remove the hard-coded data and replace it with real live dynamic data from the database. At the top of this file, we want to import Astra. So let's do an import, and we're going to want the create client. And it's going to be from the npm package we just installed, which is Astra.js collections. Next, let's create another function where we can create the connection to AstraDB. We want a constant of the Astra client, and it's going to need an await because it's going to be running asynchronously. Create client, and when we call the create client function, we want to pass in the same credentials that we set in our terminal. So it'll be Astra database ID, and we're going to want to read it out from our environment variables, which will be process env, and it will be Astra DB ID. Next, we want to do the region. And last but not least, the application token. And you can rename these environment variables, but make sure you're consistent for whatever you set in the terminal, you also set it here as well. And the great way about doing it this way is that there is no chance we're going to commit our passwords or our tokens. And the next thing we need to do when we're connected to the database is make sure we connect to a key space or a namespace. And we can do this here or later. The reason I want to do it here is we're only going to be using one key space in this application, so we can keep it a bit simpler. So we'll create a constant, and we're actually going to go into the namespace and into the collection. and then we will return the collection. And this is mostly config that you can copy and paste from DataStax documentation. So now the fun part, you're gonna see with not much code, we're gonna make this work. So we need to list all the developers, and we can use the find method with an empty query object. And we'll add items to this later on to query and filter the data. So now into our get endpoint, let's put a constant, and we're gonna say client, and we're gonna do an await, and we're going to call DB. But because we've done that, we must make sure we make this function async. So now we've got the database client, we actually want to query it as I mentioned. So let's create another constant, developers, and we're going to want to await for the find, and we're going to pass an empty object as I mentioned before. But do note from DataStax documentation, it does recommend not to have an empty where clause in the find, as this will return all the rows from the partition. But luckily we're using the JavaScript library that has a default limit of 20. But it's usually better to put a limit just in case something goes wrong. So in the body, let's delete the hard-coded data we were returning, and let's put developers. Let's go have a look at see how this has affected our application. Our front end is now broken. And I did say that the front end would work with no changes, and that's still the case. We have one little tweak to do, and bear with me, let me explain why. Let's go to the back end, and you will see we have 4 results coming out of our API, which is coming out of the real database. So 4 results is great. I know I only inserted 2, but I had 2 already there that I showed you at the beginning of the video. So we will add a delete so we can delete the duplication coming up shortly. But what you notice about this data, it is not an array, it's not a collection of developers, it's actually an object rather than the collection. So this ID, we actually need to move into the object and make it a collection. And we can do that quite easily. We can use object keys from JavaScript on the developers data that we just received back, and then we can do a map over it. And for each key, we want to return the ID, which will be the key, because this is the key up here. So for each one, we want to grab the key, and that's the ID. And then we want to spread the rest of the data that we have in the object. So it becomes, rather than 3 properties, 4. And we want to pull out that specific key. So now if I hit save and go back to here and refresh, this data should look like the same structure as we had before. Refresh, and now it is. You can now see it is a collection of objects, and the ID is inside each object rather than being the key. So now if we go to the web page, you can see it has worked. We actually have 4 items. Yes, there's duplication, and we're going to delete some of those, so that gives us a chance to test our delete button that we're going to add shortly. This isn't looking very pretty, so maybe we should add Bootstrap to style up the list page. And Bootstrap allows us to have some pre-built styles, so therefore we don't have to build everything from scratch. You may choose to use other styling tools. Some common examples are like Material Design or Tailwind, or write it from scratch if that's something that you want to do. We can add Bootstrap really quite easily to the project with Svelte add. So if we say Svelte add, and we say latest, and we add Bootstrap. Now it's been added, we must do npm install to actually install the dependencies. Now let's start our application again, and you will see some of the fonts and padding and margins has changed slightly. So what we'll do is we'll actually change in the front end, so in the UI, we'll actually change the UL and LI into a card. So what we can do is we can remove the UL, and then in here in the LI, let's make some changes. So what we can do is say div, and it's going to have a class of card. And let's just give it a bit of a style here. We'll do it inline for now, just to keep things all in one place and simple. We'll give them a bit of a margin between each one, and then we'll want to float them left. Here you could use flex or grid as well if you wanted to. And then inside the card, let's have the card body. And then we're going to have h5 for the title. And we can give it the right class, so therefore Bootstrap can work its magic. And we'll say title, and this can be the person's name. And then we will also want underneath that a paragraph with the class card text. And this could be their bio, so we're pulling this out of the loop. And then let's have a footer so we can have some action buttons to delete and click on their link. So we can say, have a div, and then we will have card, and it will be the footer, and we can go text muted to make it style a little bit different. And now we've done that, let's have a link to click on the person's URL. Give it a class button, and we'll make it a success button, which will make it look like a positive button. But the delete button we will make like an error or a danger button, so it's obvious that you're gonna do something destructive. And then we could just say more info. So if we hit save, I should reformat this a bit. Let's have a look. So that looks much better already, and we haven't, again, written much code. We didn't write any CSS. So we've got this, but I did show you it with a picture at the beginning, so we're gonna have to add avatars to the data we've got. So that looks good. Yes, there's duplication, and yes, we need to add a delete button, so therefore we can remove some of the duplication. So next, let's add a form to the website so we can save the database in the data from the form rather than using curl commands. So let's create a form under the title and above the loop of data. So let's have a look. So we'll do a HTML form, and we'll say on submit, and we're actually going to then prevent the submission because we don't want it to reload the page. So prevent default, and then we're going to call the save function, which we haven't created just yet. Then using Bootstrap's styling, we can create a nice looking form here. We'll give it an input group, and we will also give it a margin bottom of 3. And inside that, we need an input field. So we're going to say type text, and we're going to give it a class of form control, and the name is going to be name, and we're going to bind the value to name as well. Let's give it a placeholder as well, and a placeholder of name with a capital N. So next we need bio. So let's do another one, and we can just change this to bio. This will be bio, and this will be bio. Next we will want avatar link. So we will say avatar, and we can put a bit more words in the placeholder, and we can say avatar URL so it's crystal clear what it is. And then we want the person's URL as well. And then next we'll want a button, so we can do an input type of submit, and then the value can be submit or save, and then we'll give it a class of form control as well also. So to save that, we get an error because we haven't declared these variables yet. So in the script section under export let data that we've already got up here, we should declare the field variables and the function save. In the save function, we're going to use fetch to make the HTTP post to our API, and the response from the API will be appended to the data collection on the page. So we need name, bio, avatar, and URL. And then we need the save function as well. So a good thing to always do is we could just do a console log to make sure the data's coming through. So we could do an async, which we'll need in a moment for when we do the fetch. So save is the function, and it's getting no properties coming in. And then let's do a console log on the data. So on name, bio, avatar, and URL, and hit save. If we go back to here, you can now see the page is working. So let's just put in the name. So if we just say Eddie, and we can say test bio, and I will just say test URL and test URL. This is test avatar. So let me change that to avatar so we can see a difference. And if I hit save, but I must open the console log first, hit save, we can see we've got the data that we had just put in the form. So we know it's working, and that's looking good. So what we can do next is actually remove the console log, and we can actually make our fetch command. And we're going to want to do a fetch to index.json. That's what we access our API in the browser. And then we're going to want to add an extra property to the fetch command, which is going to be an object with the type. So it's going to be method post. And then we want to make sure we passed in the headers. And then the headers is going to be another object, and it's going to be content type, and it's going to be application JSON. And then we want to pass in the body, and we're going to want to JSON stringify that to go over the wire. And we're going to want to pass through our properties. So name, bio, avatar, and URL. And then next, we're going to make sure we want to chain the promise. We want to use then. And what we want to do is get the response, and we want to make sure we JSONify it, turn it into JSON. And then next, we can add it to the list. Because if we did nothing now, it will get created, but then it wouldn't add to the list after a page reload. So it'd be nice to add it to the list when it is created. So what we can do next is say new data, and then in our ES6 function, we can say the data is now equal to new data, and then we'll spread the existing data to get added to a single collection. So now that we'll make a post to our backend API. But I know you're thinking, Eddie, we haven't done a post on our backend API yet, but we can do that. So now let's go to our API, and we have the get. So to do a post, it is really quite straightforward. We would just add another export, and we will say it's async, and we'll say function, but we're going to call it post. And then it's also going to get a request and a response. Let's open the function body, and then it's going to return some data. So I'm just going to do that right now, and I want to say a status 201, which is the HTTP status for creating something. And then in the body, we can just return true for now. And the reason why I'm doing that is I want to console log the data that is getting sent to the API, so we can make sure that in the terminal that the data is being received correctly before we write more code and maybe we figure out something's wrong and we don't know where it's gone wrong. So we should check each stage we can, and the more checks we do, the less problems we'll have. So let's do console log of the request body. If I hit save, go to here, this hasn't changed. Go to the terminal, and it's reloaded. Let's send some data and see. So we can say test name, test bio, test avatar, and test URL. Hit save, and we can see it's gone through to the API because that's where we had the console log. The other thing you can check is also in the network traffic. In the network traffic, if you have it open before you do your save, you can see the requests going back and forth. And if you have too many, you can filter by fetch XHR, and then you can see that this is being sent as a post to that URL, and you can see the post body that is being sent. Yes, the response is invalid because we haven't got any good response coming back. We haven't done that yet. So next we want to actually send this data to DataStax's database AstraDB, and you're going to see how straightforward it is. It's literally one line of code. So let me show you. Remove our console log. And we're going to want to do something very similar to before, which is have a constant of the client. So we can get that for this function in this scope. And then after that, we're going to want to get the data, and it's going to be from the request body. And then all we're going to want to do is actually make a request to DataStax. So we're going to get the response from the request we're making to DataStax. We're going to do an await on the client, and we're going to do create. And that is it. Now AstraDB is going to receive that data, and it's going to create a new document in our database. And then the return we're going to want to update. So 201 is definitely correct, but what we're going to want to do is make sure in the body we return the ID in the data. So what we can do is in the body, ID is going to be coming from the response, and it's going to be called document ID. And then we're going to want to spread the data that got sent to us as well. So we hit save, and as you can see, that's really straightforward. Instead of using the find function that we used earlier, we're actually using the create function. We pass the data to it. But do know, in this example, we're sending the Astra database, the entire post object. But in a real world project, you'd want to select the fields coming in, or the ones you want, and also sanitize and validate the data. So now let's try that again. So let's add me number 2 again. My bio is going to be GitHub star of the year. My avatar URL could be my GitHub one, which is github.com/editjout.png, and you can do that for any of your GitHub profiles. And my URL is going to be very similar, but without the PNG. So we've got 4. If I hit save, as you can see, it appears at the top immediately, and it's been saved in the database and persisted. And you can see we've got 201 back, and the response is now correct because we've got the right response being returned. So that has worked. And if I refresh the page, the order might change, but you'll see it still persists. So we've got 5. Okay, there's like 3 of me there. We need to start deleting some. If you're enjoying this video, give it a thumbs up. You can see how straightforward it is to get started with these awesome open source tools. So now that we're in the API section, let's just quickly throw in a delete and show you how straightforward it is. And it's even simpler than the 2 we've done already. So as you've guessed it, we're going to do an export. We're going to do async function, and we're going to say it's a delete, but delete is a reserved word. So we're going to say del, And we're also going to get the request and response, open the function body, and you guessed it, we will want the client, and we'll do an await DB. And then we want to get the ID from the request that comes in. So when the front end makes a delete request to the back end, we're going to need the ID so we know which one to delete. So we can get the ID, and we'll get it from the query object, and we'll say get ID. And then for the DataStax, all we need to do is await the client, delete, and pass it the ID. And then we want to return some data so the front end knows that it's complete, and we could just return status 204. That means no content. So now that works, let's add it to the front end, add that delete button. So to add the delete button, we can add it to the footer of the card that we have already, and we can say it's a div. We can give a class of button, and we'll say that it's button style danger. And then on click, we're going to want to call the delete function with the ID. And let's also pull out the ID here. We're not using the avatar yet, but we will shortly. Close this off and we'll display the delete. Now if we go to the web page, we have a 500 because obviously we haven't defined delete yet. So let's define that. So for the delete, we're going to want to do a fetch as well, but much shorter than the one we have already. So async function, and it's going to be delete. We're going to want to receive the ID in this function as well. And then we're going to want to do an await with a fetch. It's going to go to the same endpoint, which is going to be index.json, but we're going to pass in a get parameter, which is why we're using the backticks, and we're going to pass in ID that we got in the function call, and then we're going to pass in the method like we did before, and the method is this time is going to be a delete. So once that completes, the promise completes, we're going to want to do a then, and then in the function of then, we're going to want to make sure we filter out the ID and to the data that belongs to that ID in the list so it can get removed. So we could say data equals data.filter, and we'll just use D for convenience here. And if the ID of the loop we're filtering over does not equal the ID that got passed into the function, then keep it. And if it does, then delete it. So we come back to the web page now that after we've saved it and the delete function, you can see it's no longer broken and we have got the delete. This should work. We have delete in the API, we have delete in the UI. They should all link through just like everything else did a moment ago. So let's try and delete some. So let me delete Eddie2 first. It's gone. Let me refresh the page to check it has gone from the database. And it has gone. Refreshed it, it's definitely gone. So let's delete a few more of these because these haven't got avatars and we want to add these again with some avatars. And yes, you could do an edit, but I'll let you do that. And if you do that on your projects, don't forget to share it with me. I'd love to see the improvements you make to this project and what projects you build with this. So let me delete all these, delete, delete, and delete. So let's add a new one. So we've got Eddie Jowd, founder of Eddie Hub. My avatar URL is here already, perfect. And my URL is going to be very similar. So let me hit save. It appears, but no image, but I have saved an image. So let me go back to the code and let me see if I can add an image. So according to the Bootstrap documentation, I can add an image just above the card body. So we can say source and we can say avatar. We'll give it a class of card image top. It'd be nice to give it an alt tag. That way people can find out what the image is about. I'm just going to put the name in its place there as well. And let's self-close that, save it, and we should hopefully see an image. And we do, so that works. So now let's try another person. So if we add Sarah, and Sarah is the community manager of Eddie Hub, and the URL will be similar to mine, but I'm just going to change the user to Sarah, and their URL will be without the PNG as well. Hit save, and you can see now Sarah's image has also loaded, and more info will go to Sarah's URL, Sarah's GitHub profile, and I can show you that now. And then more info on my one will go to my GitHub profile as well. That's looking pretty good, but as the list gets longer, we're gonna probably want to do some searching. So let's add an extra form field just above the current form we have so we can use the operators from DataStax and do some searching. So let's add it between the title and the current form. And we're not gonna have to add a new function to our API, we're just gonna have to tweak the existing get one with an if else. You're gonna see how beautiful it is. So here we will create a form, and for this form again, it will be on submit. Let's prevent default, and we're going to want to perform a search. Just like before, we're going to do something very, very similar. We're going to have a div with a class of an input group as well. And we will give it a margin bottom of 3. And then inside the input group, we're going to want a HTML input. It's going to be type text. And it's going to also have the form control class. We're going to give it a name of keyword, and we'll want to bind it to the value keyword. And let's give it a placeholder so it's nice to read, and we can say search. If we self-close that, and keyword is going to be red because we haven't created the variable yet, so let's quickly do that now at the top. So we can say let keyword equals an empty string. But we do need a button for search, and we will need a function for search as well. So let's add the button first. We can do an input, it will be type submit, and we'll have a value. This is what's displayed on the button, so we can just say search, and it's going to have a class also of form control. And it's going to be self-closing. And for the search, we can add it here under the delete. It's going to be a async function called search, and we're going to search with no parameter coming into the function because we'll use the keyword from the form. And then we're going to do an await on the fetch, which is also going to go to index.json like before. And we're going to pass in a query parameter like we did with the delete, and it's going to be keyword. And then we will want to get the response like before, get it as JSON. So we call the JSON function. And then what we want to do is replace the data. So new data is going to replace the existing data. And we're going to do that with data equals new data. So hit save. Go to the web page. We've got an extra form field at the top. I can close this to give us a bit more space here. So we can search. But it's not going to work here because we haven't made a little tweak to our API. So what we need to do next is go back to our API, and then we're not going to add a new function this time. We're going to tweak this function ever so slightly. What we're going to do is we're going to change this empty object to be an operator. The operators available are like equals, not equals, contains, greater than, less than. I'll list those all at the end and show you a link. What we want to do to our existing get is pass in an operator with a variable that someone sent in with that data if they've sent it in. So what we can do is we can say let developers equal an empty array, and then we can say if there is a keyword that's come in, then do a filtered search. But if there isn't, then do the search that we were doing before. We remove the constant because it's already defined as a let. So let's actually grab the keyword, which would be from the request, query, and then we will get keyword. And so if there is a keyword, then let's do something different. So what we're going to do is we're going to still save it to developers, and we're still going to do an await on the client, and we're going to do a find. But the difference, we're not going to pass in an empty object. We're going to say we want to check for the name field to be equal to the keyword that's coming in. Therefore, if a keyword is sent in on the request, we're going to filter by it. And if there isn't, we're going to bring back all the data. So let me hit save. And let's give that a go. So here we've got 2, and we know we have 2 results. Let me add another Eddie at the moment. So if I just add myself again, and we'll say rather than founder of EddieHub to make it different, we will say GitHub star of the year, and my avatar URL hopefully exists, and my URL also exists. But I could do, rather than my GitHub, I could do my YouTube channel, which just means I need to change that. So hit save. So now there's 2 of me, but you can see the difference, founder of EddieHub and GitHub Star of the Year. So if I refresh this, there is 3 results. So let me do a search. So if I search by Eddie Jowd, it should now only give me 2 results. And you can see it's only given me 2 results. We haven't deleted Sarah, we've just filtered it out. So now if I did reload the page or add a reset button, you can see all 3 results are there, and the search is really fast. But let me delete the duplicate and we can just test that the delete still works as normal. Delete. Okay, so we've deleted the duplicate and we're back down to 2 results. Most data retrieval will use a where clause containing an operator to return a range of rows to return. The operators available are equal, not equal, greater than or equal to, less than, equal to, within, and not within. And the where clause can use any of these operators applicable to the data type defined. The storage schema used by the document API internally indexes all the values, so any column can be used with an operator. Another example would be to use the in operator, where we could say name exists within a set of keywords if we're doing multiple keyword searches. You can read more on the DataStax documentation site, link in the description below. So let's summarize what we've done in this tutorial. We have created a full stack application using SvelteKit and DataStax's AstraDB NoSQL database. Using their document API that displays a list of developers, which allows the user to create new developers as well as filter from the list and delete. It is straightforward to get started with SvelteKit and AstraDB. Here are some actions and ideas for you to try. Move some of these sections into components. There's a delete button already, but you could add an edit button to edit the data. Don't forget to share what applications you've built with these technologies in the GitHub community.